start, even though you guys ready? Here's where I want to start. I want to ask you this question. I got to try to remember which I'm about to show you here. If I said to you, is this representing a project scheduling with known activity times or uncertain estimated activity times, which would be your answer? No. No, exactly. If I ask that same question in problem number 21, no, not 21, I'm sorry, I meant to use 14, I guess it's the other one. Number 14, known or uncertain estimated activity times. Now, if you're kind of not getting this yet, you need to catch on that when you see there's 3 different times, most probable, pessimistic, optimistic, for each activity, that's what's trying to tell you that this is estimated activity times instead of known. And when you see the activities like this, where there's only one given time, that's known activity times. And the difference is that when you have this, you've got to take a step where you take these 3 times for each activity and convert them into known activity or into expected activity times, so you can do it just like you did if we had known activity times. So from there, I want somebody to help me, or at least talk me through how to figure out the expected activity time for this example that was on PowerPoint for activity G. What would be the math on that? What should I do here? Anybody jump in anytime? Let's start with the 1.5 most probable for G. What should I do with that? Try to get the expected time for activity G. These are those 2 formulas when you have uncertain times, when you've estimated the time. You have these steps before you start doing your forward and backwards pass to find the earliest starts and the earliest finishes and everything. What would you do to calculate the expected time for G? Let's start with the 1.5 now. Go, jump in.
Multiply it by
4 times. 1.5 times 4 equals 6. Then do what? Add the other 2 on the outside. So in this case, G has a 1 and a 5, so I'm adding 1, which makes 7, add 5, which makes 12. Now do what? One more step to get us to the expected time. Divide by 6. We used 4 right there, and then we used another and another, making 6 of them. We divide by 6, the expected time for activity G would be 2. You've got to get that down. When you have a problem like this, it's probably going to ask you to do at least 1 or 2 or 3 expected times, and then also 1 or 2 or 3 variances for a activity. Let's do variance for I. Get me started on activity I. This was G. Now let's do I. I want to start with the variance. So the first step is what would be in the parentheses, which is what?
30.
What was the first step on that?
Oh, 5 times 4 is 20.
No.
Oh.
If we were doing the expected time. But we want to do the variance.
Oh.
Do the variance formula.
5 minus 2.
Not 5 minus 2.
8 minus 2.
8 minus 2. The longest amount of time minus the shortest amount of time. Most probable is not even in this formula. Those 2. So in this case, 8 minus 2 equals 6. What's the next step? Divide by 6. Divide by 6 equals 1. Next steps. Square it. Equals 1. The variance for I will be 1. Those 2 steps are the first 2 steps that, well, for sure the expected time, before you can go on with this problem. But you will need to do variances, but I want to save you time. Did I do what you said?
No.
Oh, okay. Real quick, I want to save you time. You never, ever need to do the variances for every activity and any of the problems I can think of. It's very important, though, that you figure out what the critical activities are. Those are the ones you're going to need the variances for, which instead of spending all that time doing how many activities here, 9, 10 activities, doing the variances, just find the critical activities and just do those. Now,
So for the G, the 4, is that automatically?
always 4, it's constant. Every time, every one of these most likely times have to be multiplied by 4. It puts 4 times the weight of what is expected from all those meetings you had to have to come up with these times. It puts a lot more weight on the expected time. Usually, the meeting, someone's saying, oh no, it's going to take 6 hours. Oh, no, I can get done in 4, let's all agree 5, then they'll probably be the most likely. And that's how you come up with these, that's how it goes. It's just you're time and time coming up with all these different times and what's involved and what is exactly the immediate predecessor of this one. Sure, D comes before F, but it's not finished right before F. And B and C are the ones finished right before F. Now I look at D may not be before F. So
What about the six?
why the 6? Where? Oh, 6 because, well, in this case, we're always using 6 numbers. 4 of them just happen to be the most likely. Then our 5th number, and then our 6th number. So here, we used 4 of these, 1 of those, and 1 of those. And every one of these, you always use 4. You put that much weight, 4 times the weight, on the most likely number compared to the shortest and longest amount of time you can take.
So it's
Always
always 6?
6. And it's always 6 here, which is not as easy to explain. But it always is. That's in stone, constant. Always 6, on both the variance and the expected value. 6 is the key. Yeah.
So for G, you're finding
Expected value. Expected time. Expected time. Here, we're doing the variance of that activity. Want me to do one more?
do we use both of these formulas when they happen at certain times? So if you were to give us something like this,
If you have this, you have to get the expected times, or there's no way of doing a forward or backwards pass.
okay.
But here, you're going to get to a point to where, okay, I've done my forward pass, I've done my backwards pass, I now know the critical path, and it's asking you for what's the probability of this project getting done under a certain time. And that's why you got to have that project variance. The only way to get the project variance is to find the variance for every activity that's critical in the critical path from beginning to end. Talking about critical path, is there another question before I? Okay, talking about critical path, let's do this real quick and find the critical path, just so we know how to find it. All right, this is a forward pass, backwards pass. We should be able to go fast. This is really easy. I know it's been almost a whole week. Let's try it though. Look at A, coming straight out of the beginning. It's 6 units of time. Any project, any activity comes directly out of the start. You start on day 0. That's the earliest start, 0. It can be finished in the amount of time it has on there, which is 6 units of time, so it can finish as early. Now I want to point out up here, the top left-hand box where that 0 is called the earliest start. That activity could start as early as 0, right away at the beginning of the project. And then the right-hand top box is your earliest finish. The earliest A could ever get finished if this project gets started is in 6 units of time. The bottom left is going to be the latest start. And if it's different than the earliest start, that means this activity could start on day 0, but it could start as late as, whatever that latest start is, and not hold up the project. That's what that latest start means. That activity could start as late as and not hold up the project, which will cost money if it holds up the project. And then the bottom right-hand corner is the latest finish. It has to be done by that time, or that's it. We're holding the project up completely. It's going to cost time. Let's go to B. B only has A before it, so it could start as early as what? Unit of time. 6. Then finish when? 10. Just add 4 to it, because B takes 4 units of time. C comes straight from A. A finishes 6. C can start at 6, but finish when? 9. Very good. D comes straight from B. You start as early as? 10. I heard it. Finish as early as? 16. Thank you. E could start as early as? 10. Very good. Finish as early as? Very good. F, here we go. F could start as early as? What'd you say, 19? No way. You can't add them together. Good. I heard someone else over here, though, said it. 10. We had a choice, though. Could have been 9 or 10. Why did we go with 10? Because it's the biggest number is the way I wanted you to remember it. If you can't remember the reason is both of these activities have to be finished before activity F starts. And even though one activity is finishing on unit of time 9, let's call it day 9, the other one's still going until day 10. So F cannot start till they're both finished, which is going to be the bigger amount of time, day 10. Let's I forgot. How much, when's it finish? The earliest finish? 20. Wow. G could start as early as 20. Very good. Just like that. You had 13 and 20 to choose from. Went with 20. Could finish as early as 22. I could start as early as, that's right, 16 or 22. We go with the 22. Add 8. We're at 30. Let's go with H. Start as early as 22. Add 6. 28. This project completion time, expected completion time, is how many units of time? 30. There's 28 going to the finish and 30 going to the finish. They all have to be finished, so we've got to go with 30. That's the earliest this project could be finished. If everything goes on time and goes through. You ready for a backwards pass? This is all review for you. Now we're doing the backwards pass. You guys start all over? No. Let's check.
I'll pick up.
Okay, all right. Now we're doing our backwards pass. Go to the bottom right-hand corner, look at the finish. The ones that are coming directly from the finish have finished as late as the whole project. So we have a 30 in the bottom right-hand corner in I, and a 30 in H, because they're both going to the end, and they both can finish on that last day. Because they don't proceed another activity. So now on I, you subtract 8, we're at 22. On H, you subtract 6, that puts us at 24. I or H has something significant about it. Which is it, I or H? And then what is it that's significant? What's it called? Critical activity. Nice circle. And how do we know? When you have your earliest start and your latest start the same number, you also will have your earliest finish and latest finish as your same number. And the difference between either one of them, the starts or the finish, will be 0. No slack. It's critical. Meaning that activity has to start on day 22 or unit of time 22 and has to be done on unit of time 30 or it's holding up the project. There's no room for play. But H could show up on day 22, but could show up on day 23, could show up on day 24 and not hold the project up. There's slack there. There's room to play. All right, G could finish as late as, I've heard some numbers here. Give me it again, with confidence. 22, no 24s. Look at G's coming from, I got an earliest finish 22, bottom left-hand corner box, and a 24 on H. So you had two numbers there. When you're going backwards, it's the smaller number, not the biggest. It's the opposite. So we're going with a 22. Subtract 2, 20. We just identified. Thank you. Critical activity. Now we're going to F. F can finish as late as 20. Subtract 10. We're at 10. Another critical activity. E could finish as late as 20 also, because it only has G after it. Subtract 3 puts it 17. Look at the slack there. E didn't show up on day 10. I'm not worried about it. I'm not even bugging them yet. They didn't show up on day 11. Still no worry. I forgot about them. I'm so not worried, right? We got all kinds of room to play there and not have to hold up the project. How much room do we have? How many units of time is our slack? That's right. Either the difference between the starts or the difference between the finishes. And you have how much slack is in activity in your future, just so you know. So make sure you realize it. D could finish as late as 22. Subtract 6, we get, what is that, 18? 16, thank you. 16, wow, a lot of slack there. How much slack? Very good. B could finish as late as? Well, that's not. Oh, good one. I didn't see that it had 3 after it. I thought it only had 2. I was only looking. I saw D and E. I said to myself it's between the 16 and 17. But there's also this 10. It has F and D and E all after it. You go with the least amount of time, which is this number right there, which we then put up here as a 10. Subtract 4 is a 6. Look at what we just found. Critical activity. C could start as late or finish as late as? How much? 10. It only has one activity after it. Subtract 3 puts us at 7. Not critical. Here we go with A. Your choice is between what two numbers before you tell me what the latest finish is? 6 and 7. So you're going to go with which one? 6. Subtract 6, you get 0. We just found our critical path. And if you don't have a critical path, then there may be a mistake on how you've set this up originally. There's almost always a critical path. I haven't experienced without one. So in this case, it happens to be A, B, F, G, I. There's your path. And if this were a project with uncertain activity times, and we had to start answering questions about what's the probability it would take this amount of time or that amount of time to finish, you would need the project variance. And by doing that, you would find the variances of just the critical activities, A, B, F, G, I, and add them together. That's the variance of the project, then square root it. Now, I want to give you a heads up, because I've seen this happen a lot of times. There's students that think it will be a shortcut if they find the standard deviation of each of these activities. So they say, oh, I'm going to find the variance of A anyway, I might as well square root it and just turn it into a standard deviation. And they'll do that for each one, then add them together and go, look, I got the project standard deviation instead of just the variance. You'll never get the right standard deviation. Almost never will it come out correctly. 99.9% of the time it will not be correct. You have to take all the variances and add them first, then square root, or you will not have the right standard deviation for the project. So be aware. All right, that's our review at that point. We got a little bit more review. Hang on, just gotta get to it. Okay. Oh, here we go. Here, there's our formulas. 4 times the middle number, add the optimistic and pessimistic, divide by 6. Here's our expected time. Here's our variances. Take the longest amount of time minus the shortest amount of time, divide by 6, then square it. There's our variance, but we only do this for the critical activity. I want to look here. Look at all these activities. A, B, all the way to K. All right. Here's our expected times and variances. We do, let's look at an output. You ready? What's the latest activity I could finish? This is an output. You got to be able to read it. 18. You see it? What's the earliest activity E could start? Very good. 6. Get the hang of it. Let me see it. How many activities are critical? Very good. You see it all to the far right? Any of them with 0 slack? It just happens to have stars in this particular, whatever the software output is. Sometimes I don't see things like stars. So you just got to recognize 0 slack. There's your critical activities. All right, so our critical path is ACFIK. Our time for this particular project is going to be 23 units of time, in hours in this case. Here we go now. We take the variance of this critical path. We add them together, and we get 2. That's the variance of the project. And if you're using the software, this is how far it goes, right here, the variance of the project. You have to then square root it to get the standard deviation of the project. Now, I tried to give you a shortcut last lecture, and I want to review that shortcut because I want to make sure we get this. This will truly, if you get this, this really makes the stats part of all this easier. I always draw this bell curve, and then I make a number line that fits the information. So as soon as I have that standard deviation of the project, I say, okay, I'm going to make this number line where each of my dashes are exactly 1 standard deviation above the expected time, or 1 standard deviation below, 2 standard deviation, 3 standard deviation. Because the empirical rule says, right down the middle, 50% to the left and 50% to the right, this is your project expected time right here. In this case, the project expected time for this project is how much time? Is it up there? 23. So this is where the 23 goes. Now, the empirical rule says 1 standard deviation above goes about there. Now look at how all I did was I visualized a little space inside where the big part of this curve curves and put my first dashes. Then I go to my second dashes right past the bigger part of the curve. Whoops. I like to stay at the same distance. And this is just a number line. The numbers to the left will be smaller, the numbers to the right will be bigger. It's just a matter of which numbers do you put in these dashes, and it's all based on that standard deviation. So 23 plus 1.414 would make this one, I went a little too far inside, or outside, excuse me, I'm going in a little. This would be 24.14 or 414. And somebody's got to calculate. You ready? 23 minus 1.414, so that's going to be 21.586. I forgot what I even said. 21.586. Does that sound right? I was calculating in my head and I couldn't keep it. Let's add 1.41. 24, 4.14, we have 25.8 something. 25.8 something. Correct me if I'm wrong. 82 what?
828.
Thank you. And then 21.586 minus 1.414. You guys? Which one? Who's giving it to you? You're pointing at him and he's looking at you. 19 point. No, I'm sorry. 20.1. 20.0. Okay, is this 20? How's that? 20 point. Any number.
What's that, 25.860?
No, 21.586 minus 1.414 equals 20 point.
172.
No. Hang on. 20. Yeah, 172. Is that what you said? Thank you. Who said it? Nobody. Mike? Thank you. 172. Okay, here we go. 3 standard deviations. Way out here. You don't even put those numbers. Are you ready? Now look at this. If I said to you, what's the probability this is going to take 23 units of time or less? Look at where 23 is at. Dead center. So you know if that question comes up, the probability is what? 50%. If I said to you, what's the probability of 23 units of time or more? That one's obvious. It would be what? 50%. Now, just look at this. Now that the number line is set up, you can literally estimate any percent I asked you. It's all because you realize that this amount of space on either side accounts for 1 standard deviation each direction. This amount of space. So look at this number line. I'm just going to arbitrarily pick a number 24.5. Look at the number line. Just look at it visually. Think to yourself, what percent would be to the left under the curve? What percent to be to the right? And now I'll turn it into a question. Are you ready? What did I just say? 24.5 is what I'm asking about. What's the probability that this project, look at it. Hang on, we're just estimating. Okay, what's the probability this project could take 24.5 units of time or more? No, more. I'm sorry, I didn't hear you. Yeah, that's not bad. I was going to say 20, 25. I like the estimate. She looked at where 24.5 landed, right there, and said, look at how much of that curves off to the left. And I was guessing 80. She's saying 75. I may even be more than 80, but I think possibly. And what's to the right? The opposite, 20% or 25% or 15%. Now, let's see if we're right. Here's the calculation. Everybody goes, oh, what am I doing here? It's so easy to estimate it that this calculation now will be obvious. You take always whatever you're being asked about and subtract the expected time. The expected time is the second number, and this way you don't have to figure out, okay, is this supposed to be negative or positive? 24.5 minus 23 equals 1.5. Now you divide that by the standard deviation of the project. 1.5 divided by 1.414 equals 1. Mike, hit me. 1.5 divided by 1.414. Kyle, hit me. Somebody, hit me.
1.06.
1.06. It's a positive 1.06. I said, what's the probability it would take 24.5 units of time or less? We've said around somewhere between 75 and 85% will be the or less. We go to our book. Back to the book. I think it's like Appendix B maybe or something. Anybody else agree? There we go. Is this the page? These are the negatives. This is if I was asking about a number. Come on. This is if I was asking about a number that was smaller than the expected time. So let's go to the positive. 1.06. So here's the 1.0. The next digit is a 6. So I'm going over to the 6. Right there. 0.8554. I just remembered I was saying it better. 0.8554. But I forgot it. I didn't ask for 24.5 units of time or less. I said 24.5 units of time or more. She said 25. I said maybe 20. We'll subtract that from 100%. We get 14.6. 6.6? No, 4.6, thank you. 4.6% chance. So it was even less than both of us thought, closer to 15%. But do you see how we were able to estimate that just by looking at this number line? That's how easy this is. Let's try another one. We're going to estimate it first. You ready? What's the probability that if it's supposed to take 23 units of time, and we have 1.414 standard deviation for this project, what's the probability it will take 22 units of time or less? Let me stare at it before you yell an answer out. Okay, give me an answer. This would be 22, look at the number line, units of time or less. 40, 30, right now, I was going to go with 40-ish, or let's go with 35-ish. Ish percent. 35-ish percent. I think it's 35%-ish. Right? Let's try it now. 22 minus 23, it's always what you're being asked about, minus the expected time equals -1. Divided by 1.414 equals 0.8, 0.7. I'm looking around for a calculator. Kyle, you're on it? You look like you were. Negative 0.7. 07? Okay, 1. You want to go kind of 2 digits to the right of the decimal because all of these charts are 2 decimals to the right of the decimal. 0.71 negative. I'm going to the negative. We guessed around, I forgot, 35-ish. Negative 7.7 down here at the bottom. I'm going all the way across to a 1. Is that right? 7.1? Which says 0.2090. 0.2090, about 21%. We were a little off there. We were a little high. So I went to negative 0.7 and then over to the 1. Is that the 1 or is that the 1? 23.89, I used the wrong one. 0.238, that's better. Closer goes. We're still about 10% off, but do you see how this is? And if you have this and set up this number line, any question, you can almost estimate what this is going to turn out to be. And it just makes it that much easier. It just makes that whole calculation so much easier that you know if you're making a mistake or not. Because most people's mistake in calculating Z is, okay, am I supposed to look at a positive or the negative? Did I just calculate the wrong one? So that's the easiest way to do it. There's that review. Let's keep going. There is no doubt in your future, either the next quiz or final, that you will for sure have to calculate the probability of the amount of time of a project that has estimated activity time. That's such an important part of this particular chapter that it is for sure you're doing, just in case you're looking for something to start with. Practice. Here we go. The last part of this chapter is crashing. This is real. You got assigned to a project, you have a bunch of people involved, you've done a ridiculous amount of meetings to come up with this, all the activities involved in doing the project, their activity time. And I told you most of my experience has been constructing projects. And I want to tell you, it's not, once the project starts, you're not done with meetings. You go through a phase, you're meeting again, double checking, how did it go, are we on track? What's the activities, does everybody agree these are still the times that are expected? And you go through that phase and meeting again. Go ahead, Mike.
I think your camera's on, or your phone's on the battery.
Oh, it's not plugged in?
I don't know. I just see like the air.
Can you plug it into another plug if it's possible? Thank you. Does it still say low battery?
Yeah.
You may have to move it to the next plug down. Some of these are active and some are not. I think there's some wires underneath that have gotten unplugged. Then we're going to keep going. Worst scenario is we'll have to use the other video in the other class. Anybody watch the first one? It was from the other class. I just wanted to see your reaction of. All right. Anybody here? You are. Yeah, I'm taking tennis lessons. Put that on the camera. No signing today. There you go. Got you covered. All right. You ready? This project, you get it all done. You're going, okay, here's our plan. We're going to get done in a certain amount of time. and then all of a sudden you're told, we would like to get this project done sooner. Could you put together what the cost would be if you could get it done in this amount of time or this amount of time? So you start getting on the phone and you're calling everybody involved in these activities and saying, hey, I know it costs this much for an activity, but if you had to add additional staff to get this activity done faster, how much would the additional cost be? And you got to do that for each activity. You got to find, you got to compare how much more money would be spent on that activity to get it done faster. Then you got to come up with which activities are you willing to spend money on in order to reach the goal of a certain amount of time or less at the least cost possible. Everybody hear that? Anytime you crash a project, it means you're trying to get it done faster than the expected time that you had planned originally. And it always costs money. It's how do you get it done faster for the least amount of money possible. That's what crashing is all about. So, here it is. This project is coming up with this new earth mover, or what's it called? Kind of paver. They do pavers, rollers, graders. The project is a new line of loaders. Management's concerned that the project may take longer than 26 weeks. To complete the project, we need to crash some activities, and here's how you do it. Here's the original project. Again, this is micro. Okay? There's the original project. You see the activities, you see the amount of time. Are we using estimated or known activity time? No. You only see one activity time for each activity. That means this is for sure going to take 6 weeks. This is going to take 4 weeks, 3 weeks, 6 weeks, 10 weeks. You see which activities precede the others. Now, I'm going to go back here. I took each activity and I put it in this direction here. You'll notice what activities precede other activities. Match that PowerPoint slide completely. You help me do the forward pass. You help me do the backwards pass. Management's concerned this project could take more than 26 weeks. You come back with the recommendation that this project is expected to take how long? 30. So it's going to take more than 26 weeks. We already calculated. We got to crash 4 activities. And the bad news is, don't get me wrong, sometimes you are crashing activities that are not critical, but you aren't really reducing the time of the project until you get through the slack. So it could be very expensive on a project that has, where's that one that had a pump? E has 7 units of slack. Now it may look like the lowest cost activity that you want to attack to try to crash this, but you've got to crash all 7 of those units of time before you really crash the project. You've got to take that into consideration. And so, usually, you got to remember, there's like 50 of these activities. So the math on this looks like, again, it's like this. Don't freak out. I'm going to break this down. And if you write the little things down as to how this is done, it will make it much easier. First of all, I want to point some things out before we get into the story again. There is not only X variables here, but there's Y variables. Does everybody see that? So that means there's 2 variables when you're crashing for every activity. Notice there's like X. The activities are A through I, I think. Is that correct? Let me go back to the list. Is that A through I? All right? And you'll notice that there's an X, A, all the way through I. And there's Y, A through I. So anytime you see how many activities there are, when you're crashing, multiply times 2 if you're trying to figure out how many variables. X and Y of every activity. All right? These X constraints are called activity constraints. Your X constraints. These Y constraints are called Y constraints. They're really your crashing constraints. The Y variables represent the amount that each activity could be crashed. Let me repeat that one. The Y variable represents the amount of each activity that could be crashed. They're called your Y constraints or crashing constraints. I always call them the Y constraints. Now notice your objective function. When you're crashing, it's always, almost always, I've never seen one that's not, minimization. Almost always minimization, because it's all about what's the least expensive way we can get this project done faster. The faster we get it done, the less likely then of cash getting eaten up because we accidentally went beyond the amount of time that the loan is in place for. And I want you to also notice that in the objective function are only the y variable. Everybody hear that? This is really one of the first mistakes students will start making is they'll write the objective function using the x variables because every problem we've had before this has used x variables. But crashing uses y variables. Okay, let's get back to the story. They said, thank you for letting us know this process is going to take 30 weeks. Now, come back and tell us which activities would be crashed and how much it will cost to get it done in 26 weeks. You get up, everybody gets on the phone with whoever brought the subcontractors that are involved in whichever each activity. Hey, you told me about, you're the one hiring the manufacturing staff, human resources, and you said it would take 10 weeks and $300,000. How fast could you get it done if more money were involved, and how much more money? And they say, well, we could get more people on it, do interviews faster, do the background checks, and we could get it done in 7 weeks, but it's probably, we gotta use more staff, so you're looking at an extra $180,000. So 300,000 goes to 480,000 if you want to get it done 3 weeks faster. And this goes on with every activity. I want you to look at activity B. What do you see with activity B that probably took place in that meeting with that conversation about crashing activity B? Exactly. That's exactly the conversation that took place. We cannot, purchasing that building cannot be done in less than 4 weeks. That's it. This is actually the absolute shortest we can get it done, and it's $100,000 in the process of getting this building, because we got to do environmental checks. I bought a lot of buildings. Anytime you even suspect there was a gas station involved, you got to do environmental 1, 2, and 3. Very costly. You do them in phases, because if they discover something in 1, you don't want to pay for 2 and 3, because they're even more expensive. Environmentals have to be done. You're looking at $100,000, title search, surveys, appraisals, all that stuff. And then you dig into closing. You can't even get to closing in 4 weeks, so this is obviously not reality. I'm never going to get to closing in 4 weeks. And so on and so on. I find it easiest to do these crashing problems if you create 2 columns. One is the amount of time each activity could be crashed, the maximum amount of time in units. So I'm going to develop 2 columns right here. And you're going to tell me what's the maximum amount of time that each activity could be crashed. Let's figure this out. Here we go. A, how much time could activity A be crashed at the most? 1 unit of time. B, 0, thank you. C, 1. D, 3. E, 1. F, 3. Is there G? Okay. G, H, I, help me out. G, 0 again? What's G? Manufactured a prototype? Okay. H, 1. I, 4. Right? Because expected to be done 8, but we could get it done 4. What you've just written down are all of your Y constraints. Ready? Here we go. A, Y sub A less than equal to 1. B, I'm not going to write B, 0. But if you had to write it, it would be Y sub B less than equal to 0. C, Y sub C less than equal to 1. D, Y sub D less than equal to 3, and so on, and so on. By finding that difference, and that's not the only reason you did this, is just to write those Y constraints. It's just a shortcut, just to let you know that it does lead you to the Y constraint. But what you did this for is the next column. The next column is the cost per 1 unit of crashing for an activity. Let me repeat that. This isn't about how much will it cost to do a full crashing. It's how much will it cost to do 1 unit of time of crashing. Now some of these are easy because they got 1s. But you've got a 3 here, a 3 here, and a 4 here. Can't believe there's not 1, 2. There's not a single 2 in there. How about that? And so you got to say, what's the cost to crash, and divide it by however many units of time you'll get out of it. because this column is cost per 1 unit of time. Let's start with A. What will be the cost for 1 unit of time crashed in activity A? I can't hear you. 20,000. If we're paying 80,000 for 6 units of time, and it's going to cost us 100,000 for 5 units of time, that is an additional cost of $20,000 divided by 1 unit. Now, I'm abbreviating because when we get to the slide with the objective functions and stuff, it's all the thousands that's been left off, the 3 zeros, all been left off the numbers. Ready? B is 0 because it can't be crashed. C, how much is C? The difference between those two divided by 1 is how much? 50K. D, the difference between those two is 150,000, but it's 3 units of time. So 150,000 divided by 3, 50,000, right? Let me do it again. The difference is 150,000, but that gives us 3 units of time. So each unit is $50,000. E, 180 to 250 is $70,000 divided by 1 means 1 unit of time, 70,000. The odds of E being crashed when we got a 20, a 50, a 50 could be slim, depending if it's critical activity or if it's just got a lot of slack. If it's got slack, there's no way this would be at 70,000. Let's go with F. Let's see, 10 to 7 is 3 units, 300 to 480 is 180, so per unit is how much on F?
60.
Well, did I skip E? Let's see, F is 60, thank you. And we go on, G has nothing, H is 1, let's do I. 350 on I goes to 650, that's 300,000 divided by 4 is something else, 75,000. And we didn't do H. That column you just made is basically setting you up to write your objective function. That little bit of math gave you those numbers. This is 20,000, remember this is in thousands. Minimize however much it costs for 1 unit of time crashing for that activity times the Y variable for that activity. Everybody hear that? So let's go straight to I. You said 75,000. That means in the objective function it'd be 75,000 times Y sub A. Y sub I. So making those 2 columns is writing your Y constraints. Y sub A less than equal to 1. Y sub C less than equal to 1. Y sub I less than equal to 4. And then using those numbers to divide in the total cost difference to get the per 1 unit cost for each activity. Wow, we didn't do H, but it's 350,000 if we had calculated. Wow. If that's crashed, that's unbelievable. 350,000 for one unit of time. Anyway, so you can write your objective function based on the column of 1 unit time. You can write your Y constraints. So those are easy now, right? But here's your activity constraints. The key to this is you either got to look at, where'd it go? This. Because writing these activity constraints is all about what precedes it. So you either got to look at that to see what precedes it, or this. And I got to warn you, you're only going to be given one or the other, most likely. So you've got to be able to read both of these to figure out which activity precedes another. Pretty easy though, right? First of all, if you're using this, it tells you D is preceded by B, F is preceded by B and C. If you're using this, F is preceded by B and C. D is preceded by B. Just giving you out warning. Because, you ready? How these are written is you start at the first activity constraint, which would be A. And you use the variable x sub whatever activity you're writing this for, A. Then you mark it as greater than equal. This is how it's done. The next one is whatever activity precedes it, x variable. But in A's case, it doesn't have an activity preceding it. So we use the 0. Now let me repeat this, because if you have the words down, you'll be able to follow the steps. When you're doing activity constraints, start with the x variable for the activity you're writing this for. the x variable for the activity you're writing for. Make it greater than equal to the x variable of whatever activity precedes it. Everybody got that? Then add the normal amount of time the activity would take that you're writing this for. A usually takes 6 units of time before we crash. How much time would it take if no crashing were taking place? You get it? Normal time. Minus the y variable for the activity you're writing this for. Those are the words that will help you decide what every spot placed there. I'm going to say the words again. The x variable for the activity you're writing it for greater than equals the x variable for the activity that precedes it plus the normal time of the activity you're writing this for minus the y variable for the activity you're writing this for. Okay, look at B. Everybody just kind of look at what precedes it. Looking. Okay, here we go. I'm going to write it right here. It says, write the x variable for the activity you're writing this for, x sub b. Make it greater than equal. Then make the x variable for whatever activity precedes it. So this would be x sub what? A. Add, what is the normal time before crashing for activity B? B, no, look at the normal time for B, 4. The regular times are underneath the letter when you're doing the forward and normal test. The 6 would be the earliest start and the earliest finish. But the 4 is the normal time. So put a 4 here, minus the y variable for the activity we're writing this for, B. So I just wrote the activity constraint for B by following those steps. Let's try F. Are you ready? The x variable for the activity we're writing it for greater than equal to the x variable of whatever activity precedes it. So what would be the x variable? Excuse me.
B and C.
What? B? What do you mean B? B or C? Which one? B or C? You, whenever activity has more than one activity preceding it, you have to write as many constraints for that activity, however many precede it. So I'm going to start by using B, right? Ready? X sub F greater than equal to X sub B plus the normal time for F, you got to find it, 10 minus Y sub F. And now I'm not done. I got to write another one. X sub F greater than equal to X sub, what's the other one? C? C, nothing changes except for that letter of the X that precedes the one we're writing it for. And we have to write X sub F twice because it has 2 activities preceding it. If they had 3 activities preceding it, you'd have to write it 3 times. And only with that one little change of the preceding activity, plus 10 minus Y sub F. Nothing else changed but that X sub B here and the X sub C there. So, G. You would do G with an X sub E preceding it, and then you would do it again with the X sub F preceding it. All right? Let me find another. I. You do X sub I with the X sub D preceding it, then you do X sub I again with the X sub G preceding it. So now look at these. Now these make sense. There's one A, there's one B, just like we did with the A before it, the 4. Where's our F? Here's F with the B before it. Here's F with the C before it. Where's I? I with the D before it. I with the G before it. You see how easy these are? You could all do these activity constraints, but we're not done. There's a little bit more to it. All right. So now you go, oh, I've got my objective function. I've got my Y constraints, crashing constraints. I've got my activity constraints. But then you've got to look at this. Either this, again, either that or that. And you've got to say which activities do not precede any other activities that go directly to the finish. And in this case, we have I and H. You have to use the X variables for any activities that go to the end, that go to the not proceed another activity. And make them, now I gotta write this down, I don't want you to forget this. This is the only one. These are the less than equal to however much time the project's being crashed to. So this project's supposed to take 30 weeks, but our management said, let's crash it to 26 weeks. Is that correct? So we got to make which activities here? X sub I less than equal to 26, and H, X sub H less than equal to 26. Those are the additional constraints that are really telling the program, here's what you really want to crash to. This is our goal. So now you're telling the program, you find the least expensive way and let us know which activities we need to throw money at to get this project done in 26 weeks, when it's supposed to take 30. We got to eliminate 4 weeks out of this somehow and figure out the lowest possible cost to do it. Okay, one more little thing. Let's just keep going. These activity constraints cannot be entered into the software. It can't be solved on Excel until you get the variables from one side all on the other side. They all have to be on one side. There's only a number left on the other side. So you got to apply algebra. You ready? Let's do 2 of these. And if this were a quiz question, I wouldn't be asking you to do algebra on every one of them. I'd say now, the first 2 activity constraints, do algebra to show me what it would turn into. So let's do the first 2. I got X sub A greater than equal to 0 plus the normal time, which is 6, minus Y sub A. Is that right? Is that 6? All right. I got a variable on the right here, Y sub A. The 0 doesn't matter. 6 plus 0 is still 6. But I'm going to have to add Y sub A to get rid of it. So whatever I do to one side, I do to the other. So I have X sub A plus Y sub A greater than equal to 6 plus 0, 6. Now it's a finished constraint ready to enter into the software. I'm going to put a 1 under the variable X sub A. I'm putting a 1 next to the variable Y sub A. And I'm putting greater than equal, and I'm putting a 6 on the right side. And there's going to be all these variables, but they're all blank in this row, except for a 1 there and a 1 there. You have all these variables at the top in the software. And you're just putting a 1 there and there. The rest are blanks or zeros. And then the right-hand side is a 6. Let's do another one. Let's do B. X sub B is greater than equal to X sub A plus 4 minus Y sub B. Okay, I've got X sub A on the right side and a minus Y sub B. So I need to subtract an X sub A on both sides. And I need to add a Y sub B on both sides. I'm doing both at the same time. So what do I have on the left now? X sub B minus X sub A plus Y sub B greater than equal to, what's left on the right? 4. And that's how you apply the algebra. All right? So, there it is. You just broke the crashing problem down. And if this were real, next thing you know is manager's going to say, hey, which activities are you crashing? First of all, how much is the least amount it would cost us to get the 4 weeks cut out of this project? How much? 200,000. 200,000 is the least we can get the cost down. Which activities are being crashed in by how much? Jump, give me any one of them. Come on. What do you see? Where are you looking? How do you figure it out? This is what your output looks like. Which activities are being crashed? Name an activity being crashed. X sub what?
X sub I.
X5.
No, I.
I'm sorry. I?
Yeah.
I is not being crashed. I don't know where it goes. I see it over there. You see it. Okay.
Y sub A.
Activity A is being crashed 1 unit at a time. Let's go to A. What was the cost for A per unit? I erased it. Darn. How much was it per, well, on the objective function, what's with Y sub A and the objective function? 20 or 50? 20,000 is right there. What else is being crashed? That's 1 week. We're down to 29 weeks. We need 3 more weeks. Y sub, say it again. F. That is how you figure out which activity is being crashed. You look at the Y variables. The Y variables are telling you which ones are being crashed. So, let me see, what was, if this was 20,000, that means 180,000, so these three must have been 60,000 apiece. Look at the objective function is y sub f with a 60. So 60,000, 60,000, 60,000 is 180 plus 20,000, there's our 200,000. We're cutting 3 weeks off of this activity spending the 180,000, and we're going to spend 20,000 to get a week cut off of activity A, and we're going to get it done in 26 weeks. With the lowest it can cost us 200,000. Is it worth it? And then everybody debates if it's worth it, and we say, let's go for it. Let's spend the extra money, because we'll save 300,000 on something that's going on the other side. Got it? Can you crash a project? I want to show you something. Hang on, where'd it go? Right here. Is this it? All right. I need to zoom this up. Can you guys see this? It looks like it's blurry. Is that blurry? Okay. You see number 23. What about it will help you recognize that whether this is crashing or not? Anybody see it? Say it again. No. 23 is over here. 22, 20, did I say 23? I meant 22 over here. 22 over there. 23 also, now that I look at it. Either one. What is it about it that's telling you this is a crashing problem? Matt?
Spacing of the.
Nah, not the spacing. Not the spacing. There's something there that's telling you this is a crashing problem.
So, crash and the.
Well, not the, if the word crash, that's not the word. If it were, I don't know. Right here, you guys. These problems will give you normal and crash costs. It will give you these a lower and higher cost. Is that the word you were saying?
I was looking at the other one.
But, and it gives you normal and crash time. And none of the other ones, no activity times, uncertain activity times, will give you this information because you only need this information if you're crashing. You won't even have the cost of any of the other problems at all because the cost has nothing to do with it. The questions are all about how long will this project take? How long will that project take? What's the probability of this taking this long or more, this time or less? This is how you recognize this crashing. It's giving you a lower cost, a higher cost. I can barely see that. I think that's 800 and 1400. This looks like a 3 to 2. So if we were doing our formula in 2 columns, it could be crashed about 1 unit at a time, and it looks like it will cost about $600 per 1 unit at a time. So our objective function, y sub a, would have 600. You get it? Look at these are all the same. I like this one. It only goes to f. This one is a 10. I can't see that. Is that an 8? It is. Okay. So 2 units a time. This looks like a wow. I can now. Is that a 7? 30. What's that then? 20? 30 and 70. $40. 2 units. Cost per 1 unit. Not all at once. I can't do it. I couldn't pick you up. $20 per 1 unit. Get it? All right. This is how you recognize them. This is how you use it. It's no different than what you see on the PowerPoint. This chapter is like really easy. Well, I just got some looks. All right, here we go. Wait. There we go. Here we go. You ready? Here. Here's our crashing problem. You can't use per CPM to do a crashing problem. It will do a known activity time problem. It will do an uncertain or estimated activity time problem. And we demonstrated uncertain activity times already last week, right? I want to do crashing. The only way to do crashing is you got to use linear programming module instead. Okay. Now, let's pretend this is new. It's going to say how many decision variables. You got to remember, there's. Hey, whoop. This is what you're going to have maybe. You're just going to say how many variables. You're going to say how many. Let me count. 1, 2, 3, 4, 5, 6, 7, 8. Is that 9 activities? So how many variables? 18. I heard it. 2 variables for every activity. Remember? 18. You get that? You put in 18. Number of constraints. Oh boy. Hang on. You just got done doing all of this. Oh my God, you forgot these two. Almost everybody forgets these. Don't do it. Don't forget. These last ones are the ones that are good. You start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 constraints. Here, 21. Max or min? Min. Always on crashing, minimizing that cost. Look at these. And then I start making them. This is x sub A, x sub B, x sub C, x sub D. And then go all the way to, I can't remember, I. And then I go y sub A, y sub B, y sub C. Now look at the objective function. You would have no numbers underneath these x's in the objective function. All your numbers would be way down here where the y's are. And then down here you have all your constraints. Some of them have nothing but blanks across here, maybe just a 1 here and a 1 there. And you fill it all in, and it looks like this. X, A through I. And then look at the top, you'll see A. Whoops, where's that? There it is. And then you got Y sub A through I, and the numbers are underneath the Y, just the way you wrote it in the objective function. Don't forget this is in thousands, 20,000, 50, 50, 70, 60, 350. Is that one? And then 75. And look at constraint 1, all right? Hang on, is that constraint 1? That's a Y. Look, where's, let's do activity constraint, right there. So I'm on constraint 8, which is activity x sub A greater than equal to 0. Remember, there's nothing there that we took to the other side. And then it was plus the usual time for x, which I don't remember, minus y sub A. So when we bring y sub A to the other side, oh, I'm sorry, plus y sub A, right? Is it minus or plus? Yeah, minus. It turns into a positive. So when we bring y sub A to the other side, it's going to be, so there should be a 1 underneath y sub A. Let's take a look. Staying in constraint 8. Going over here and right there, y sub A. So this should also be a greater than equal and then a 6. Let's go all the way over. There's greater than, there's 6. Let's do B. B is almost just like it, except it had x sub A behind it. So there should be a negative 1 under x sub A for this one. This one's greater than equal to 4. There's the y. Whoops. Where's y sub B? Gone.
It was 0.
Oh, thank you. No, wait, the y sub B is, that's right, x sub B is what I meant. X sub B, thank you. Where's x sub B? There it is. X sub B was the one, no, x sub A. X sub A was the one that precedes B. When we moved it to the other side, it turned into negative x sub A, so that's why we put the negative 1 there. I don't know, which y is this supposed to be? Isn't this supposed to be a y sub B? I don't know, that's weird. I don't know, I'm confused. Here's y sub C. Anyway, you ready? We got it all in there. We just solved. My question for you is, which activities are being crashed? Name what activity is being crashed on this output. Where are you looking?
Y sub C.
Y sub A, how many units? Y sub F, how many units? What's your total cost? Think of the time it took to enter all those in. Because you had 21 constraints that you got to go across and put the 1, the negative 1, the greater than, the less than, and the numbers. But the same thing. You've got to be able to read this output just so you realize it's the Y's you're looking at. The Y's are what activities are being crashed and by how much. Okay? You good? Let me look, see what else I got. Just make sure. What is this one? This is the one we were working on? It wasn't. Okay, what's this one? What's the amount of time this project will take? This is an arbitrary output. What's the amount of time this project will take? Expected time? 18, very good. Look at where those who were able to answer this quickly looked. They said, they looked at earliest starts, latest starts, earliest finish. It's the latest finishes that will give you the project time. The biggest number of latest finishes is 18. The expected time for this project is 18. Critical path is ACEG. has yeses there, it has 0 slack, and it literally gives it to you right there. Let's look at this output. Whoops. What's the expected time? Oh, this one's giving 30 right now. Okay, they're all here. All right. You know the homework. It's due in 2 days. We're starting the next question.
Yeah, those extra constraints for crashing that you said are the last activities that aren't preceding anything else?
Yeah, before you go, here we go, look at this one. She just asked about those extra constraints that tell the program how many units to crash to. How many of those extra constraints that tell the program what you need to crash to are in this picture? 2. X sub what and X sub what? H. Very good. Does that answer your question? Do you see how they can do it? He sees only 2 activities going to the
Oh,
end.
yeah, I was gonna ask, you set them less than or equal to what the crash time goal is?
That's right. And if this said, you are to crash this project in the least expensive way to, 12 units of time, X sub G less than equal to 12, X sub H less than equal to 12. Using the X though. All right, let's look at this one. Before we go, one more. How many activities, constraints, would you have to write to tell the program what you're crashing it to with this one? 1. X sub H. And this, now, I want you to notice something. There's the picture. There's that. This problem says write the objective function for the crashing problem above. Then it says write all the constraints for the above crashing problem, assuming it needs to be crashed to 9 units of time. Make sure and apply algebra to at least 3 activity constraints. Everybody see that? Not all of them. You're going to write them all. Apply algebra to just 3. Any 3 you want. I'll be happy. Any 3 of them that deserve algebra.
When we were writing the objective function earlier, you told us like you only do the y's.
Y's.
On the program, you have the x's and the zeros.
No. You have all the variables in the program, but you only write numbers underneath the y's. Where is it? Hang on. Edit. Boom, boom. See how there's no numbers under the x's?
Okay.
But they're all on the y's, because only the y's are going to be the objective function.
Okay.
You have to have every variable listed. That's why you see all the other ones there. Exactly. All right? I was just going to show you one last thing. I forgot what it was. What was it? I was just about to say something. What was it? Darn. That's it? Oh, yeah. I almost got this. Yeah, you know this is your homework, right? It was something about this. Three activities need algebra. This is due in 2 days. I don't know what to say. I'll see you then. I can't remember. It was definitely going to help you whatever way.
I have another question. Is the only reason you do algebra is so it works in the software?
And Excel, however you're going to solve it. If you can't solve it without doing algebra, it can't be answered.
So it's not like it's a different constraint?
No, you haven't changed it all. You just rearranged it so the variables are on one side. See, in this one you got here a 1, a -1, and a +1. That's usually underneath those variables.